Today we have an interesting topic that we'll be looking at, and it is basically on statistics. And when we're talking about statistics, mainly it has to do with the collection of data, and there are different types of data that you can have. And then it also involves certain parameters that you can use to interpret that particular data that you've collected. And of course, there is a visual representation of data, which makes the interpretation of the given data or the results to make it easy. So basically, statistics is also divided into two, but today we'll simply be looking at the core curriculum or the first part of statistics. Now, first of all, I want to list and explain defining the parameters that we use and the main visual representations that we will use. Some of these you might remember from earlier mathematical lessons that you might have had earlier, which includes the bar graphs, the pie charts, and we'll also add some more additional ones as means of trying to interpret any collection of data. So we'll start by listing the parameters and explain them, and then of course, as I've mentioned that we've got different types of data, we're going to divide it into random data, which is ungrouped data, and as well as grouped data. So let's start by listing and also defining these parameters. So the first is that you always have what you call a variable, and then a variable is also linked to a frequency, the frequency. These in fact are the main parameters or the main parts that define data. And then of course, we will also have what you call the mode. We will have what you call the median. And then the median is linked to something else which is called the median position, but for now I will not write it. So we have also what you call the mean, and there's another which is called the range. So these are the main parameters that we'll be looking at. So when we're talking about a variable, it is basically the subject matter of the data that you're looking at. So this like subject and then in brackets data. Now normally it's also called the independent variable. That's what you call the variable where you have the horizontal axis. That is where you will always have your variable. And then your frequency is the dependent variable. That has to do with the frequency. The word frequency simply means how many times does a certain variable appear in that particular data that you are looking at. So frequency has to do with how many times. How many times for a specific variable. I'll put it in quotes, but it's easy to see when we have described that certain or given a specific type of data, and then we try to interpret that. Now, when it comes to the mode, this is the variable that appears numerous times. So that's the variable that appears numerous times. Numerous times. You'll understand this better when I give specific examples. And then the median. So the median, it actually depends on the type of data that you have, but mainly it is the variable that's in the middle, or the value that is in the middle. That's what we call the median. So when I would say city inombolo some if you are talking about random data. So if you have a list of certain numbers, then you would have to arrange them first in ascending order, and then you should be able to find the variable or the value that is in the middle. And then the mean, this is just the average. Now, of course, I'll show two formulas on how you can calculate the mean depending on the type of data that you have. So for now, we just write mean as average. Then the range, you will normally be asked the range in random data. Sometimes they can ask you even in group data, but mainly it is on random data, where it is simply the highest value or the highest variable minus the lowest variable. Now, some books or some literature, you will find that it's written as the highest value minus the lowest value. Now, the different kinds of visual representations that we'll be using, the easiest one is also what you call a pictogram. Now, this mainly uses pictures because picture has to do with pictures. So normally, where you find that it represents a human or a number of people, and then they've given a picture. The head represents a certain number of people, and then the full-size body or half the body of a person represents a certain number. So that's mainly a pictogram. So we're using pictures to describe a particular form of data. And then, of course, we have what you call the bar chart or a bar graph. We have what you call a frequency curve and a frequency polygon. Now, these oftentimes are confused, but I'll be able to show you the differences, because a frequency curve, it's a curve and it's normally a sigmoid. So we usually draw it when we are looking at the cumulative frequency curve. That's normally what you draw. And then the frequency polygon, that is where you join the plots using a ruler. So the difference between a frequency curve and a frequency polygon is that a frequency curve, you draw it using freehand, it's smooth, and then a polygon, you use a ruler to join your plots. And then, of course, we have the scatter diagrams. Scatter diagrams. These are mainly used for the interpretation of, to show what you call correlation between two types of values. We do also have what you call the stem and leaf plots. Stem and leaf plots. Now, of course, because we are in the core curriculum, that's what we are describing today. So we'll only be looking at these. Otherwise, we also have what you call a histogram, but that one is used in the extended curriculum. Now, let's start by looking then at the types of data that we have, so that we can make the distinction of the specific formulas or equations that we shall use, depending on what type of or what parameter you are talking about. So we've got ungrouped data, ungrouped data or data, and then we have grouped data. So for starters, I'll just summarize everything that you need here to know, especially with regards to the parameters that you use, and then we'll give an example. So when you're talking about ungrouped data, this one is basically random. So it's random data which is not grouped. Then, of course, you can group it and arrange it, where we now start to form what you call group data, where you've got intervals. So for this one, we are looking at frequency tables. For this one, we're looking at frequency tables. We have frequency tables. We also have cumulative frequency tables. Frequency tables. But of course, the cumulative frequency table angeke sifike lapho because leyo seyika-extended, but I want to show the pathway is the pathway is part of the core, where we have a table where we're going to have the variable and the frequency. And then what you'll also notice in our group data, we will have what you call a frequency, in fact, not frequency, but I meant to say a median position. You will need to calculate the median position when you are given a frequency table to determine the median. So the median position basically has the formula n plus 1 over 2. And then this is normally for values which are less than 100, where n is less than 100. If n is more than 100, you just use n over 2. But then that one is where you basically have what you call term intervals, where you have intervals. Now, the intervals are part of the variable. So, for instance, you will have a variable which says maybe learners who were size 1 to 5, then 6 to maybe 7, or maybe 6 to 10. So that's an example of an interval. And then the next thing that you also want to note in terms of the distinction, the mean here is calculated using this formula or the equation where you say the sum of is what you call a class with value. There are two, in fact. The first one is the sum of the variable times the frequency all over the sum of the frequency. So this is the one that we're going to use for our group data, for the core curriculum. Otherwise, as we are extended, intervals, that is where we will find what you call a class mean value and then the frequency. So this is the main one. When it comes to random data, the median, we will get the median by just arranging the numbers in ascending order. So numbers in ascending order, arrange numbers in ascending order. The key word is ascending order. So basically it means you first arrange the numbers starting with the smallest to the biggest number, and then you find the variabilities in the middle. But in this case, because we normally have a table, you will have to use the median position, and I will show how we determine that. And then the mean, the formula is easy. You just find the sum of the numbers that you are given. So sum of numbers for given values over the number of given numbers. So what does this mean? If I've got 10 numbers, I will add the 10 numbers equal the answer. Then the answer they divide by 10. That is how we get the average. Specifically for ungrouped data or random data, where I'm just given random numbers. So these are the main formulas. So I want to make sure that you are truly able to make a distinction between the two, because you shouldn't in any case confuse. It depends on the type of data that is given. In which case, if they are given ungrouped data or random data, this is the formula used for the mean. And if you are given group data, this is the formula that you use. Otherwise, for the range, you normally be asked in ungrouped data, where you just, after you've arranged the numbers in ascending order, you subtract the bigger number from the smallest one. Okay. Now, this is just a summary of what you want to look at. Now, let's look at an example, starting with the ungrouped or random data. So I'll write a list of numbers and I will show you how to use the different parameters that we've just looked at. So let's say I have this list of numbers. I am given 1, 2, 4, 4, 7, 3, 8, 9, 5, 4. So these are the numbers that are given. And then I'll be asked to determine the mode. I'll be asked to find the range. I will be asked to also determine the median and also calculate the mean. So the first thing that I should do, maybe let me write below, find the range. What would be the range of these given numbers? What would be the mode? What would be the median? What would be the mean of these numbers? So what you do, always when you are given random data, you should first arrange the numbers in order, in ascending order. Remember, starting with the smallest. So if you look at these numbers, maybe let's first count how many they are. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 numbers. Now, let's arrange them in order. So the first one will be 1, obviously, and then followed by 2, followed by 3, followed by 4, 4, 4. Notice that we've got 3 4s. And then it will be followed by 5. You do not have a 6, so follow it with 7, and then 8, 9. And then let's ensure that we have all the 10 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, and 10. So I've arranged the numbers in order. So this will make it easy for me to determine both the mode and the median. And also the range, it will be easy. So to calculate the range then, that will mean I will subtract 9 from 1. So it will be 9 minus 1, and the range is 8. So this is how we get the range. Now for the mode, remember, from our definitions of the different parameters, we said the mode is the variable that appears numerous times or many times. So when you look at these numbers, which number appears numerous times?
4.
So it's 4. So therefore, 4 is our mode. Now I should mention that sometimes you can have more than one mode. So depending on how the data appears to be. So for instance, if I had 3 3s and 3 4s. So therefore 3 and 4 would be the mode. So sometimes you can have more than one mode. Then when it comes to the median, I'll show you a trick here which always works depending on the number of numbers. So which is why I noticed that earlier I started by counting how many numbers I have. So you notice that the number of numbers, I've got 10 numbers. 10 is an even number. So because 10 is an even number, it means I've got 2 numbers in the middle. And if you've got 2 numbers in the middle, you need to add them and find the average. That will give you the median. So which means, in fact, if I look at this, it appears that 1, 2, 3, 4, 1, 2, 3, 4. So 4 and 4 is the median. So they are in the middle. So therefore, because 4 and 4 is in the middle, I only need to have one number, which is the median. So I'll need to find the average of these two. So it will be 4 plus 4 divided by 2. So this is 8 over 2, which is 4. So the median is also 4. Now, let's say I was given 11 numbers or 7 numbers. So if the numbers that you have are giving you an odd number, like I'm saying, if I had 7 numbers or 11 numbers, that would mean there is only one number in the middle, and that would be easy to determine that. Okay, now let's move on to the mean. So the mean, remember we said this, for random data, the formula is the sum of even numbers divided by the number of even numbers. So the sum of the numbers is simply for you to add these, the given numbers. So I will add 1 plus 2 plus 3 will give me what? 6. 4 plus 4 plus 4 will give me 12. 5 plus 7 will give me 12. And 8 plus 9 will give me 17. So that means the mean will be 17 plus 12 plus 12 plus 6. So notice that this would be 6, 8, 10, 27, 2, 3, 4, 5. So the sum of the numbers is 57.
It's 47.
2, 3, 4, 5.
6 plus 2, 8 plus 2, it's 10 plus 7, 17.
Oh, yes, thank you, right? So it's 6, 8, 10, 17. Yes. So when you add the 1 there, it should be 47. Thank you. So 47 divided by 10. So these are the numbers that I have. So it would be 4.7. Now, there's something that you notice for any given data when you're doing your calculations. Your median and your mean should be relatively closer to each other if the statistics is correct and the calculations are correct. So when you notice now, the difference is a difference of 0.7. So if, for instance, if I had maybe my mean to be 10, yet my median is 4, then that's not a good data. Or it would also mean that the calculations that I've done are not quite correct. So I'll have to check. So this is one way in which you can be able to see and check if your calculations are right. Okay, so this was the mean and the median for random data. Now, let's look at grouped or table frequencies. Frequency table. Now, there are 2 ways in which grouped data can be presented. You can have, because I also want to introduce what we call tally marks. So you can have a representation of data which is random like this, but see 0, 1, 1, 1, 2, 2, 3, 4, 7, 5, 6, 4, 3, 2, 2, 3, 3, 4, 5, 8, 8, 8, 9, 10, 9, 9, 5, 5, 6, 6, 7, 7, 2, 2, 4, 3, 1, 1, 2, 5, 9, 10. Okay. This is just random numbers that I've put randomly. And then what they will do, they will ask you to complete a table. So I want to show how. So we learn the variable here, strategy, and then the frequency. So depending on how the data, or maybe it's shoe sizes for learners, but normally you're looking at size 0. And then what you will do, your variable, you notice that in these given numbers, they are from 0 to 10. So you've got 0, 1, 2, 3, 4, 5, 6. Then we'll try to make another, only to raise it up so that it's quite here. So you have something like this. You have your variable, got your frequency, so you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then also, before I show the frequency, there will be a third column that will be here. So this will be the tally marks, and then the frequency. Now, I will also add another column, which is normally called the fourth column. This is where we will use this one when we're looking at how we can calculate the could be important in the calculation of the mean. Now, so although this might be quite a grueling exercise, or an exercise that would be a bit of a tedious exercise, but you still have to do it. So what you have to do, from the given data, which is random, you want to count how many zeros do we have here. So we have just 1 0, so which means this would be 1, that would be the frequency. We'll do the tally marks last. So we don't have any other zero. Then how about the ones? Oh, 0 didn't put it. This is 1, okay. Then how do I divide this one? So it's not 0, it's not 1. So we've got 1 0, so which means this would be just 1. And then how many ones? This is the first one. 1. Let's go by column. So 1, 2, 3, 4, 5. So we've got 5 ones. So we write down 5. How many 2s do we have? 1, 2, 3, 4, 5, 6, 7. We've got 7 2s. Right? How many 3s? 1, 2, 3, and 4. 4, please. And then how many 4s?
5.
Where's the big one? Oh, I forgot this one. And then how many 5 rather 4s? Another 4 here, we have 4 here. We have 4 here. 1, 2, 3, 4. How many 5s? 1, 2, 3, 4, 5. 4, 6. 1, 2, 3. 4, 7. 1, 2, 3. 4, 8. 1, 2, 3. 9. 1, 2, 3, 4. 4, 10. 1, 2. So make sure that you also recheck your work to be sure that you have actually highlighted and selected all the numbers and you have written them according or corresponding to their variables. Okay. So I might need to erase this one, the top part, because we've already had all the numbers or the values. Alright, so now that you've written the variables, the frequency values corresponding to their variables, the next step now, it is to do what we call tally marks. And tally marks get fun now. No, I don't know if you've seen it in the movies. Or now let's go with the side. This is what I normally do. 1, 2, 3, 4, 5. So each forward slash represents 1. And then the fifth one is always across. So this is 5. So which means that for the 0, I'll just have 1 forward slash. That represents 1. For 1, I will have 1, 2, 3, 4, and 5 across. For 5. And then for 7, I will have 1, 2, 3, 4, 5 across and leave some space. That is 5. Then 6, 7. So 2 forward slashes after it leaves some space in the middle. Then 5. We've already established that. So it's 1, 2, 3, 4, 5 across. 1, 2, 3, 4. 1, 2, 3, 4, 5. I'm sure you can be able to fill in the rest. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, and 1, 2, 4 slashes. Now, this is where it gets interesting or important. Let's start by finding, let me erase this. Let's start by finding the mode. What would be the mode? Remember, even if it is a table, you always look at the frequency. Which value has the highest frequency? Which variable has the highest frequency?
2.
So you notice 2 has the highest frequency. So because it has 7, there is no other number which is greater than 7 here. So therefore, the mode is 2. Now, how about the median? So now, because we have a table, we are going to calculate the median in a different way. Remember that formula? We will start by finding the median position. So the median position uses the formula n plus 1 over 2. So what's the value of n? The value of n represents the sum. The frequency you. So can you add these numbers? What do you get? It's a total. So we need to add all these numbers. And then they will give us the total or the sum of the frequency.
42.
42. Okay. So that would be then 42 plus 1 over 2. So 42 plus 1 over 2 will be 43 over 2. What will be the answer? So that should be what? 21.5? So it will be 21.5 or 21 and a half. Now this is not the answer, which is why you should write TH there. The median position, because this is position. In other words, this information simply means, or this value simply means the median is in position 21 and a half. So what you do then, you go and look for position 21 and a half in your frequency. So how do you locate that? You are going to add the numbers chronologically downwards until you reach 21 and a half. So how do you do that? So this is position 1, and 1 plus 5 is what? Is 6. So this means this will be position 2 up to 6 is in the second row. So 6, so that is 6, plus 7 we get, 6 plus 7 we get 13. Then 13 plus 5 we get 18. Now notice that 18 plus 4 will give us what?
22.
22. So that means the 21 and a half actually lies within this region. Because we started by calculating from the top. So 1 plus 5, 6, plus 30, that is 7, plus 7, that is 13. Then that would be 18. So which means 18, 19 is in this region, 20 is in this region, 21 is in this region, which also qualifies for 21 and a half, 22 is also here. So which means up to position 22, this is where we get the value. So therefore, then look at where it corresponds. So position 21 and a half is in this range, and it is corresponding to the variable of 4. Therefore, the median is 4. Now, when we are calculating our mean, it should be close to the median, because remember, that will tell us that our data is, or in fact, the first, it should tell us that our data is accurate and also our calculations are correct. So now, let's calculate the mean. So remember, the mean, we said if you have a table, then you will use the formula which the sum of the variables, each corresponding variable times each corresponding frequency divided by the sum of the frequency. Now this is where the fourth column becomes very important. So remember, I've written the column here which is V times F. So this basically means you will find the product of each corresponding variable with its frequency. So basically it is this column multiplied by that one. So 0 times 1, any number multiplied by 0 is what? 0. 1 times 5? 5. 2 times 7? 14. 3 times 5? 15. 4 times 4?
16.
5 times 5?
25.
6 times 3?
18.
7 times 3?
21.
8 times 3?
24.
And 9 times 4?
56.
And finally, 10 times 2.
20.
Now, we will need to add all these numbers. So remember, our sum of the frequency, rather, we noted that it was 42. So now we need the sum of the product of the variable by its corresponding frequency. So in other words, we need to add 0 plus 5 plus 14 plus 15 plus 16, 25 plus 18 plus 21 plus 24 plus 36 and finally plus 20. So please add that for me.
194.
194. Divide that by 42. Now our answer should be closer to 4.
4.6.
4.6. So this, now ideally our answers should be correct to 3 significant figures. Was that answer exact?
No, it was 4.619.
619. Yes, please give me the whole number.
047.
047.
619.
619. Now, because this answer is not exact, we will have to round it up to the nearest 2 decimal, rather not 2 decimal places, but 3 significant figures. That's the rule. So notice that because we have a 1, which is our targeted value, and a 9, the 9 will always add there because it is at least 5. So the answer is 4.62. So we have a difference of 0.62 with regards to, or rather relative to our median. So like I said, our answers between the median and the mean should be closer to each other, just to show that this is correct. Now, of course, if you were to be asked the range now, let's conclude with that one. What would be the range? If you were to be asked the range of this data, remember the range is the highest value minus the lowest value.
10 minus 0. 10 minus 0.
10 minus 0, yes, we still consider 0 as part of the data, so you can't just say because it's 0 it's nothing. It's because we do have a value for the frequency. So So we should consider that. So the range will definitely be 10 because it will be 10 minus 0. So the answer is 10. So this is where we conclude our topic for today. We were just looking at statistics. So next time we will look at how we can apply the parameters now. Rather the visual representation, whereby, let's say after we have completed this, calculated the different parameters, now represent this in a bar chart or represent this in a frequency polygon or even a frequency curve. So next time we'll look at that. Otherwise, stay tuned for more. Cheers.